Hello. You already have the basic information about absolute functions as described in the last video. Now let's look into the characteristics of absolute function. So, as you know, the absolute function returns you with a non-negative real number as an output. That means if we feed in a negative number, the output is negative of that, a positive. If we feed in a positive number, the output is a positive number. So let's try to graph it and see its characteristics. So I will do it for a few values of x. So let's say these are inputs and the output is fx. And we are talking about absolute function. Fx equals to modulus of x, we sometimes say, or absolute value of x. So let's consider a point -2. If we feed in -2, we get +2 out. If we feed in -1, we get output as +1. For 0, you get 0. How about 1? The same number is repeated, right? And 2, same number is repeated, 2. Like this. Now, on a graph, which we have here, let's plot these points. So at 0, we have 0. At 1, we have 1. At 2, we have 2. Likewise. Similarly, at -1, we have 1, and at -2, we have 2. So -1, 1, and at -2, this. As you know, the domain of our function is all real numbers. So every point in between is considered. So we can join them with a straight line, which is like this part of the line, you remember, is like y equals to x, correct? And then this part of the line is like y equals to -x. So what we have done, minus of these values, correct? And you get our absolute function. And this is our function, absolute x, correct? Now, let's look into the characteristics. 1. Do you see it goes from quadrant 2 to quadrant 1, correct? So we can note that as one of our characteristics. So we see it goes from quadrant 2 to quadrant 1. Why do we say that? It goes from 2 to 1. Arrows are pointing like this, and we are saying going from 2 to 1. Why not from 1 to 2, or from origin to this place and origin to this place? Well, let me remind you, whenever we see or read a graph, we have to read it from left to right, left to right. Always see a graph from left to right, okay? So going back to this, so now it goes from 2 to 1. Do you get it? Now, again, we will read it from left to right. And just to make that point very clear, next characteristics I'm talking about is the interval during which the function is decreasing. Do you see it decreasing? As we go from left to right in quadrant 2. So we say that the function decreases in the interval of -infinity to 0. So this is a way of writing interval from -infinity to 0, where both these numbers are not included. And as you know, infinity can never be included, right? Okay, now second, when does it decrease? It decreases from -infinity to 0. How about this part? And then it increases, correct? So we say it increases from 0 to +infinity. We need not write plus, it is understood. And infinity never can be included. So it decreases till 0 and then increases thereafter. What else do you notice here? We see at 0, what do we have? We have a corner. Well, this is very peculiar of an absolute function. So we kind of a corner, right? It is a sharp thing, right? It's not a round kind of a function as you could see in y equals to x squared. So corner at origin. So let me write 0, 0. How about x and y intercepts? X-intercept is 0. So write x-intercept is at x equals to 0. How about y-intercept? Y-intercept is also at y equals to 0, right? So at origin, we have both the intercepts, all right? How about domain and range? Domain is all real numbers. So x belongs to real numbers. Correct? Perfect. How about range? What do you think? What is the range? Range is all real numbers, or there is some restriction? Range belongs to all real numbers, but there is a restriction. You see, it's only greater than or equal to 0. It doesn't go to the negative half at all. So y is greater than or equal to 0. So the range is restricted, right? And we see it opens upwards like a parabola, y equals to x square, right? Let me now talk about some other properties like end behavior. Do you remember what is end behavior? End behavior is how does our graph behaves when we are approaching positive infinity or negative infinity. So that means negative infinity is this direction, correct? So if x approaches negative infinity, what happens to y or the fx value? It approaches positive infinity. We say when x approaches negative infinity, y approaches positive infinity. Why are we using approaches? Only because we can never reach there. We can only approach. And how about when x approaches positive infinity? That means this side. What happens to y? Y approaches positive infinity. So both ways it approaches positive infinity. Do you see that? That's the end behavior. Another important property which I'd like to focus on is symmetry. What kind of symmetry do you see in this graph? Can you tell me? Symmetry. You can see it's symmetric about y-axis, isn't it? All the points, if I draw here a line, then this distance is same. It's like a mirror image with y-axis as the mirror placed on. Do you see that? It's called even symmetry. So for negative x value, for example, for -1, what do we get? 1. Even for 1, we get 1. For -2, we get 2, which is same as the value of the function at 2. Correct? So we have even symmetry. So even symmetry is even. That means what? Y-axis is line of symmetry. Is it okay? Even symmetry sometimes is also referred to as line symmetry because there is a line along which the graph is symmetric. So here y-axis is the line of symmetry. And as I told you, you know what is f of -1? Is 1. And what is f of +1? Is also 1. Similarly, f of -2 is what? 2. And f of +2 is what? Same number, 2. So what we see is f of any value in the domain of x minus x is same as f of x. And if that condition is met, f of -x is equal to f of x, then we say the function exhibits even symmetry. Okay? Don't confuse with even degree function, okay? It's even symmetry. So, there we are with our absolute function, and we see so many properties. 1, it goes from quadrant 2 to 1, it decreases from -infinity to 0, increases from 0 to infinity, corner at the origin, x-intercept at origin, x equals to 0, y-intercept also at origin, y equals to 0, domain, it belongs to all real numbers, and range, it belongs to all real numbers, but y is greater than or equal to 0, end behavior. When x approaches -infinity or +infinity, y value approaches +infinity. And symmetry, it has even symmetry. Correct? These are basic properties of absolute function which we are going to explore or exploit in future. Critical points which we should consider to draw absolute function are -2, -1, 0, 1 and 2. Just as we take points for a line. Right? Well, can you tell me some more characteristics about this function? Yes, we can. Do you see what is the slope of the function in quadrant 2? It's -1, right? And what is the slope of the function in quadrant 1? +1. And it remains same all throughout the quadrant, correct? In quadrant 1, it is plus 1 all throughout. You can take any points. The slope will be plus 1. Same, if you take any points in quadrant 2, slope will be minus 1. Okay, now that brings to us to a very, very important question. Question for you is, this graph looks very similar to our quadratic function fx equals to x square. Correct? Now, how is fx equals to x square and gx equals to absolute x different? Can you list just 3 properties where x square and absolute function differ? Think about it and then put it down. Okay? I think you should, because we have covered those 3 properties in today's lecture also. Okay? Fine. So, go through it and try to understand absolute function. We will see now in the next video how to represent the absolute function on a number line, how to write inequalities in terms of absolute function, and how to solve inequalities. Okay? Good. Have a great day. Thank you.